So, we can solve quadratic equation by extracting the roots by following certain steps. So, these steps in solving a quadratic equation by extracting the roots, I hide it in a term, or I hide it in an acronym, which is what we call as NEAR. Okay, good day everyone. So today is our first day of class. So we are going to discuss first lesson for the first reading week. So what will be our first lesson? So this is chapter 1 of our lesson. This is all about quadratic equation. Later on, we'll find out what we call quadratic equation. So as our lesson number 1, we're going to focus our discussion on introduction to quadratic equation, as well as solving quadratic equation by extracting the roots. So you are expected here to know the meaning of quadratic equation at the same time to find out on how are you going to solve quadratic equation by extracting the roots. Okay, let's start it by knowing first what quadratic equation is. Quadratic equation it defines as a second degree equation in one variable. A second degree equation. So if you've seen an equation uh, in a second degree, then we are pertaining to a quadratic equation. But it's not always that whenever we've seen equation whose highest exponent is 2 is right away um, a quadratic equation. So a quadratic equation is a second degree equation, or an equation whose highest exponent is 2, which involves only one variable. So we are only going to focus on quadratic equation involving one variable, because there are quadratic equations also which involves two variables. So again, the first definition of quadratic equation is that it is a second degree equation in one variable. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c is equal to 0, wherein a, b, and c are real numbers and a must not be equal to 0. So the reason why a should not be equal to 0 is because if a is 0, that equation will not be anymore called as quadratic equation. So that will be the basis for us to come up with the quadratic equation. The value of a there in an equation ax squared plus bx plus c is equal to 0 should be must not be equal to 0. Come up with a quadratic equation. So your a should be greater than 0. Your a should be greater than 0. So in that equation, in ax squared plus bx plus c is equal to 0, so that is what we call as the general form of the quadratic equation. Again, it's the general form of the quadratic equation. By the way, it is a quadratic equation if your a is greater than 0, because we are only focusing on a quadratic equation whose a is positive. I'm not saying that if your a is negative, it's not anymore quadratic equation. So we are only going to focus on quadratic equation whose a is positive. That's why its a is greater than 0. So as I was saying, that given equation ax squared plus bx plus c is equal to 0, that is the general form of the quadratic equation. Now, in that general form of the quadratic equation, ax squared plus bx plus c is equal to 0, that first term is what we call as the quadratic term. That is the term wherein we can determine that we are dealing with quadratic equation. If the quadratic term is not present in the given equation, then it is not called as quadratic equation. So the quadratic term, that's the term where you can see the highest exponent. So the highest exponent na 2. So we call that as quadratic term. Then the second term, we call that as a linear term. You have discussed before the linear equation. When we say linear equation, the highest exponent of it is equal to 1. So in this given equation, it only involves one variable. So the second term of that equation, the variable x has an exponent which is equal to 1. So we call that as the linear term. And the third term is called as the constant term. So let's see there in the given equation that is for the constant term. So again, in a given quadratic equation, the first term is the quadratic term, the second term is the linear term, while the third term is the constant term. Next, so there are also equations in the following forms that are also considered as quadratic equation. So we need to say it's not always that we can come up with a quadratic equation which is have quadratic term, linear term, and constant term. It's not always like that that we can encounter complete quadratic equation. But I'm not saying that these equations are incomplete. These equations are also considered as quadratic equation. Let's take for example, first one. So the equation ax squared plus bx is equal to 0. So if you're going to compare this to the general form, the quadratic equation, so the constant term is not present in the given equation. So according to here, where c is equal to 0. But even though c is not present in that given equation, given form of equation, so we can still consider that as a quadratic equation. Second, the equation in the form ax squared plus c is equal to 0. In the second equation, so it is an equation wherein b is equal to 0. So this time you do not have linear term. You do not have linear term. So, but even though you do not have linear term, as long as the quadratic term is there, so we can still consider that as a quadratic equation. The third one is ax squared is equal to 0. So what's missing there? So in that given equation, b and c is equal to 0. That means we do not have linear and constant term. Only the quadratic term is present in that given equation. So even though b and c is equal to 0 are not present in the given equation, as long as the quadratic term is there, still we can consider that as quadratic equation. So it's not always that the quadratic equation is in 3 terms. Always present yung quadratic, linear, and constant term. There are times that we can encounter equations wherein the linear term is not there or the constant term is not there, or both linear and constant term are not present in the given equation. And now let's have these examples here. So in example number 1, you are here going to identify if a given equation is quadratic equation or not. So the given is 3m plus 8 is equal to 15. So if you're going to look at the given equation, you cannot find there a term whose highest exponent is 2. So that's why for number 1, we cannot consider that as quadratic equation. So it's not quadratic equation. Number 2, x squared minus 5x plus 10 is equal to 0. So obviously, on the first term pa lang, you can already find out there the highest exponent of the variable, which is 2. And it only involves one variable. It's just like the given equation is already written in the general form of the quadratic equation. So obviously, number 2 is a quadratic equation. Number 3, 6 minus 2x plus 3x squared is equal to 0. So what have you noticed on this given equation? So the given equation here was not arranged in the right form, which is what we call as the general form of the quadratic equation. But even though it was not arranged in general form, but still we can see there a term which has the highest exponent, the 2, which has 2 as the highest exponent of the variable, and it only involves one variable. So it's just like you write number 2 the opposite way. But still, even though it's not written in general form, number 3 example is still considered as quadratic equation. Number 4, square root of y squared minus 3y plus 5 is equal to 0. As you can see, so it has the highest exponent of the variable. It has 2 as the highest exponent of the variable, and it only involves one variable. But on example number 4, the first term, which is the quadratic term, it's we are getting its square root. So when you get the square root of a term whose exponent is an even number, or whose exponent is 2, it's the same way that we are canceling the square root sign and the 2. So if the square root sign and 2 will be cancelled out, so, what will be left is just y. So in that case, we are not going to come up with an equation whose highest exponent is 2, because when we simplify square root of y squared, that will be equal to y. So that's why number 4 is not quadratic equation. Now let's have number 5. Number 5, that's 3x times the finality x minus 2 is equal to negative 7. So at first, you will not say it's quadratic equation. It's because you will not see there a term whose highest exponent is 2. But if you're going to look at the given, if you are going to make use of the distributive property, you'll find out that you'll come up with a term whose highest exponent is 2, whose highest exponent of the variable is 2. Look at the first part. 3x multiplied by x will come up with 3x squared. So, dun pa lang, you'll find out right away that a given equation is a quadratic equation. So, those are the examples wherein we are asked to determine if a given equation is quadratic equation or not quadratic equation. So, quadratic equation can be solved in different methods. So today, we are going to discuss one of the quadratic equation by extracting the roots. So how are we going to solve quadratic equation by extracting the roots? So we can solve quadratic equation by extracting the roots by following certain steps. So these steps in solving a quadratic equation by extracting the roots, I hide it in a term, or I hide it in an acronym, which is what we call as NEAR. The word NEAR. So the letters NEAR. So the word NEAR, I guess I have that as the steps in solving quadratic equation by extracting the roots. It's because the word near, I guess, is the best word to describe your dreams in the future. That means you are getting nearer to what you want to achieve in life. So that will happen if you are going to continue what you have started. So continue studying, because all the things that you want to be in the future, that will happen if you first finish your studies. So focus first on your studies, on what you are doing right now. Then later on you'll find out that you are already there on the thing or on the thing that you want to achieve in life. So there are problems that you will encounter, but those problems are just there to make you strong. So there are no problems that we cannot solve. So all problems can be solved. Yun nga lang, you just have to find the right solution for it. So problems are just there for us, that, that is for us to make, for, that's there uh, for us to be strong. So again, near is the best way to describe what you want to achieve. Ano ba yung near na sinasabi natin? First step natin is NE. NE stands for need to write the equation in the form x squared is equal to k. Excuse me. So, if you are going to solve the quadratic equation by extracting the roots, the first thing you are going to do is to write the equation in this form. As x squared is equal to k. What have you noticed on the equation? The equation is not the same as the general form of the quadratic equation with linear term and constant term. So in this form of the equation, we only have the quadratic term and the constant term. K there is the constant term. So if you do have the quadratic term and the constant term in a given equation, so you can solve that quadratic equation by using extracting the roots. So we can, I guess that's the best way that we can solve a quadratic equation whose linear term is not present in the equation. So we can solve it by extracting the roots. So that is by rewriting it first in the form x squared is equal to k. Next, a. A stands for, and if k is 0, you can find out right away how many roots a given quadratic equation has. So, if your k is 0, it has 2 real roots. So, right away, if you have written the equation in this form, in x squared is equal to k, and you find out that your k is greater than 0 or a positive number, then the solutions has, the given quadratic equation has 2 real roots. But if your k is equal to 0, just like, for example, if x squared is equal to 0, for example, so it has 1 real root. So why did we say it has 1 real root? So a quadratic equation has 2 solutions. But how come that we can come up with 1 real root as a solution? For the reason that its solutions are the same. So that's why if your k is equal to 0, it has 1 real root. Then if your k is less than 0, so according to this, it has no real roots. So that's imaginary number. So if your k is less than 0, meaning to say it's negative, it has no real roots. So since we are not yet dealing with imaginary numbers, so if we encounter an equation whose k is less than 0, we are going to solve extracting the roots. So the answer there is undefined. And the last is R. R stands for, according to this, right away, get the square root of both sides of the equation, find the solutions. So we are just going to find the square root of both sides. So whatever you do on one side, we'll also do that on the other side. So if you find the square root of the left side of the equation, you can also find, you are also going to find the square root of the term on the right side of the equation, because we are dealing with equation. So whatever you do on one side, you will also do that on the other side to apply the concept of equality. So in order for us to solve quadratic equation by extracting the roots, all you have to do is to apply our steps, which is what we call as near. Now, let us answer examples of quadratic equation wherein we are going to apply extracting the roots as a method in solving for it. So let's have here number 1. So the given is x squared minus 100 is equal to 0. So look at the given. The given does not have linear term. So it is a quadratic equation in the form ax squared plus c is equal to 0. So only the quadratic term and the constant term are present in a given equation. So if the given equation is like that, I guess the easiest way that we can solve the given quadratic equation is by using a method which is what we call as solving quadratic equation by extracting the roots. So what's the first thing we're going to do? According to the first step, we have to rewrite it, or we have to write the equation in the form x squared is equal to k. So in that case, since it is written x squared minus 100, the first thing you're going to do is to move negative 100 to the right side of the equation. So if you move negative 100 to the right side of the equation, so since it jumped the equal sign, so the negative 100 will change its sign. So from negative 100, when you move it to the right side of the equation, that will become positive 100. So all 100. So what will happen is that it will become x squared is equal to 100. So when you move negative 100 to the right side of the equation, it's the same way that you made use of a certain property, particularly the addition property of equality. So you just added 100 on both sides of the equation. So that on the left side, negative 100 plus 100 will be cancelled out because that will be equal to 0. And 0 plus 100 on the right side will be equal to 100. That's why it will end up to x squared is equal to 100. So in that case, we are already on the right form. So the next thing we are going to do is to get the square root of both sides. That's according to the steps. So we are going to get the square root of both sides of the equation. As I was saying earlier, whatever you do on one side, you will also do that on the other side. So if you get the square root of x squared, you will also get the square root of 100. So in getting the square root of it, the square root of x squared is equal to x, because it's just like we cancel out the square root sign and 2. Then the square root of 100 is 10. We know that the square root of 100 is 10. But the usual that we know, when we get the square root of a certain number, we only, lalo na if a given number is a perfect square, so the usual answer na binibigyan natin is a positive number. So for example, square root of 100, we know that the square root of 100 is 10. But the truth is, square root of a certain number is two numbers. That number is the positive and the negative of the square root of that number. So for example, we do have square root of 100. So the square root of 100 is not just 10. It's positive and negative 10. Bakit positive and negative 10? Diba, when you say square root, that is the number that when you multiply it by itself, the answer is the one inside. The one inside the radical side. So if you multiply a number, the answer should be the one inside the radical side. So if you multiply 10, positive 10 times positive 10, that would be equal to 100. If you multiply negative 10 times negative 10, that's also equal to 100. So that means when you get the square root of 100, it's not only the answer is 10, but also we are going to consider negative 10 as the answer. Because the quadratic equation has two solutions. So it's not only positive 10, but also negative 10. So that positive 10 is what we call as the principal root. So when we ask to find the square root of a certain number, hindi pa natin alam kung paano solution yung quadratic equation. We are only giving an answer which is what we call as the positive root. If you're asked square root of 100, your answer is 10. Only 10. Because 10 is the principal root. But in quadratic equation, solving quadratic equation, it's not only the positive root is important, but also the negative root. That's why when you answer square root of 10, when you solve quadratic equation by extracting the roots, the answer is positive and negative 10. So the solution to the equation x squared minus 100 is equal to 0 is or are positive 10 and negative 10. Is that understood? So for you to understand it more clearly, let's try another example. Let's have this example. X squared minus 81 is equal to 0. So the equation is written in general form wherein linear term is not present. So according to the steps that we have to follow, the first thing we are going to do is to move the constant term to the right side of the equation. So if we're going to move that, we come up with x squared is equal to 81. Then the next thing we're going to do is get the square root of both sides of the equation. So we know that the square root of x squared is x. Then 81 is a perfect square. So we are going to get the square root of 81, and we know that the square root of 81 is 9. That is the principal root. But also, square root of 81 is also negative 9. So that's why when we find the answer for the solutions of x squared minus 81 is equal to 0, the answer will be x is equal to positive and negative 9. So you want more examples? Let's try this example number 3. Example number 3, the given is x squared minus 625 is equal to 0. Similar examples to number 1 and number 2. Again, move the constant term to the right side of the equation. Then, get the square root of both sides of the equation. The square root of x squared is equal to x. Then, 625 is a perfect square. By the way, paano nga ba natin malalaman that a given number is a perfect square? So, all the numbers from 1 to a number from 1 to infinity, all the numbers from 1 to infinity, if you're going to multiply it by itself, the answer there is a perfect square. Example, 2. 2 times 2. So the answer is 4. So the number 4 is a perfect square. Ibig sabihin, when you get the square root of 4, that's equal to 2. Because that is the number na minultiply mo sa sarili niya. Example, 10. 10 times 10, 100. So 100 is a perfect square. The same way that 625 is a perfect square. So the question is, what is that number that when multiplied by itself, the answer is 625. So you'll find out that it is 25. So the square root of 25 is, the square root of 625 rather is 25. That's a principal root. But since it's quadratic equation, so we are also going to consider the negative root, which is negative 25. So that's why solutions to x squared minus 625 is equal to 0 is or are x which is equal to positive and negative 20. So hopefully naintindihan na natin. But what if the case is like this? Look at example number 4. So if we're going to apply by using the first step, by moving the constant term to the right side of the equation, we come up with x squared is equal to 45. Then the next step is that we are going to get the square root of both sides of the equation. So on the left side, when we get the square root of x squared, the answer is x. We know that because it's a perfect square. But on the right side, it's 45. So there's no number that when you multiply that number to itself, the answer is 45. So there's no number like that. So instead, what we are going to do is to get factors. Get the factors of that number. 45. What are the two numbers that when multiply, the answer is 45? Ano ba yung mga yun? It can be 15 and 3. But if you're going to look at 15 and 3, both numbers are non-perfect squares. So ibig sabihin, you are going to factor that number wherein one of the factor is perfect square. One of its factors is a perfect square, while the other is a number, the other is a prime number or composite number whose factors are prime numbers. So, factor that number wherein one of its factors is a perfect square. So, what would be the right answer? That's 15 and 3. What else? 9 and 5. So, in 9 and 5, meron ba doon sa dalawang numbers na yun, na kapag multiply mo yung isang number sa sarili niya, ang sagot is kahit ano sa dalawang numbers na yun. So, 5, wala naman, di ba? How about 9? So, we can multiply it, number 3 by itself. The answer is 9. So, if you find out that number, so that means you are dealing with the right factors. So, 45, the right factors would be 9 times 5. So, let's write first the one which is what we put as the perfect square. So, in that case, 9 is a perfect square. So, what are we going to do next? Since 9 is a perfect square, so we can find its root. So, what is the square root of 9? That is positive 3 and negative 3. But what will happen to 5? The 5 will be left inside the radical sign. So that's why we come up with an answer which is x is equal to positive negative 3 square root of 5. Because since 5 does not have any more factors wherein one of its factors is a perfect square other than 1, then that 5 will stay inside the radical sign. So it's just saying that the solutions to the quadratic equations are irrational numbers. So that's positive negative 3 square root of 5. So naintindihan ba yun? So para mas maintindihan natin, let's try another example similar to it. So let's have example number 5. So that's x squared minus 75 is equal to 0. So move the constant term to the right side of the equation. Then it will become x squared is equal to 75. Then get the square root of both sides of the equation. So when we do that, on the left side, the square root of x squared is x. We know that it's already x. But on the right side, 75 is a number wherein there's no numbers. But there's no number when you multiply it by itself, the answer is 75. So the same way we did on number 4, we are going to factor 75 wherein one of its factors is a perfect square. What are those factors of 75? Let's say factors niya 15 times 5. Look at 15 times 5. 5 is a composite number. 15 is a 5 is a prime number. 15 15 is a composite number. Ibig sabihin, it has factors. So, but the factors of 15, which is 5 and 3, are both prime numbers. So that's why 15 and 5 are not the factors to be used as factors of 75 for us to solve the quadratic equation. Let's find out other factors. What else? What other factors of 75? Of course, less than natin 75 times 1. What's the other factor? That's 25 times 3. Look at 25 times 3. 3 is prime already. 25. Yung 25 ba, mayroong number? 25 ba, may number na kapag hindi pa sa sarili, kasabot ay 25? Yes. And that is 5. So that's why the right factors for 75 are 25 times 3. So, 25 now is a perfect square. So, you know that the square root of 25 is positive 5 and negative 5. Then, since 3 is a prime number and there's no factors of 3 wherein one of its perfect square other than 1, then 3 will be left inside the square root sign. So, that will come up with an answer which is x is equal to positive negative 5 square root of 3. Oh, nawanin nyo na yun. Hindi natin kung meron pa. How about if the example is like this? So, we do have two constant terms here. If that is the case, since both negative 9 and 55 are constant terms, so we can combine it as 1. Pwede natin siyang pagsamahin. So, just like how we solve quadratic equation by extracting the roots, the first thing we are going to do is to move the constant term to the right side of the equation. So, what will happen will be x squared is equal to 55 plus 9. The negative 9 will become positive now to the when we move it to the right side of the equation, because since it jumped the equal sign, so the sign will change. Or it is the same way that we may use of addition property of equality. You added 9 on the left side and you added 9 on the right side. So negative 9 plus 9 will be cancelled out. Then what we will have is just 55 plus 9 on the right side. Then 55 plus 9 is 64. Then we have to square both sides of the equation. We have to get the square root of both sides of the equation. So since 64 is a perfect square now, so we can easily get the square root now. So the square root of x squared is x. The square root of 64 is 8. Again, we are not only going to get its principal root, but also its negative root. So, para hindi kayo malito, right away, when you are solving quadratic equation by extracting the roots, susulat mo agad yung positive, negative, then yung square root of a certain number. So, the solution to the given example of number 6 are positive 8 and negative 8. Did you get example number 6? Let's try another example. So let's have your example number 7. The given is x squared minus 15 is equal to 14. A similar example to example number 6. So what we're going to do, move the constant term, move negative 15 rather to the right side of the equation, and it will become x squared is equal to 14 plus 15. 14 plus 15 is equal to 29. So that's why we have to get the square root now of both sides of the equation. So we know that x squared, square root of x squared is equal to x. But if we're going to look at 29, 29 does not have factors, or one of its factors is a perfect square. So if that is the case, it is not like the same the other numbers that numbers that we find factors where one of its factors is perfect square. In the case of 29, there are no factors of 29 wherein one of its factors is a perfect square. So that's why when we are going to solve number 7 for the square root of 29, it will stay as square root of 29. Yun nga lang, we're just going to add positive and negative of it. So put positive and negative square root of 29. Because 29, as I was saying, is not have factors anymore, wherein one of its factors is a perfect square. So it will stay as it is. All you have to do is just add positive, negative before that square root of that certain number. So that's how we answer number 7. Next, number 8. How about in the case of number 8, that is x plus 5 positive square is equal to 64. So in the case of number 8, we are going to, since it's a binomial term, or what we call as a square of binomial, so we are going to treat x plus 5 there as one term. That was raised to the second power. It's just like x squared is equal to 64. So we are going to treat x plus 5 as one term, then was raised to the second power, so that we can make use of extracting the roots. Paano? All we have to do is to get the square root of both sides of the equation right away. Then in that case, diba, when we get the square root of x squared, the answer is x, maka-cancel yung square root sign, pati yung 2. So ganun din mangyayari dito. When you get the square root of the quantity of x plus 5, so maka-cancel din yung 2, yung square root sign, then 2, ang matitira ay x plus 5. And on the right side, since we are going to find the square root of 64, so 64 is a perfect square, we can come up with the square root of 64, which is positive, negative 8. But we're not yet through. Why? It's because there is still constant term together with x, that plus 5. That plus 5 here, we still have to simplify it because this 5 and this 8 are both constant terms. So we still have to combine them as 1. Yun nga lang, since positive, negative 8 yan, para hindi tayo malito, we have to separate both equations. So we can come up by move, the first thing what we're going to do is to move the constant term positive 5 to the right side of the equation. Then it will become x is equal to negative 5 plus or minus 8. Pwede mo namang hindi na pag-iwalayin, pero mas malinaw kung pag-iwalayin natin siya. That plus or minus there, you have to separate it for us to come up with the right solutions. This is one example wherein our answer is not always the same expression na pinagkaiba lang is yung sign. Isa ay positive, isa ay negative. Ito, it's a different case. Because meron pa tayong 5 dito, it's not that we can say right away that the answer is positive, negative 8. So we still have to combine for similar terms because this is a constant term. So move it to the right side of the equation. You can move it after 8 or you can move it before 8. Ganun din naman yun sa mga nauna eh. When you move, you can do it or you can move it before that number or after that. So, when you move positive 5 to the right side of the equation, it will become negative 5 because once it jumps the equal sign, the sign will change. And also, we made use of subtraction property here. So, let us separate the two solutions of the equation. This positive, negative here, we are going to separate it. So, we're going to form two solutions. So, that is x is equal to negative 5 plus 8 and x is equal to negative 5 minus 8. So, ito yung positive, ito yung negative 8. So, in that way, we can easily answer the given equation. So, for the first equation, this one, when we are going to answer negative 5 plus 8, so we'll come up with an answer which is 3. And when you get the answer to negative 5 and minus 8, we come up with the answer which is negative 13. So look at its solutions. It's not the same as, it's not same number na pinagkaiba ay positive, negative. It's two different numbers. So one of the solution is 3, the other solution is negative 8. You have any questions? Now, let's have this example number 9 for you to understand it more deeply. Similar example to number 8. X minus 12 quantity square is equal to 121, or the square of the difference of x minus 12 is equal to 121. So the first thing we're going to do is we have to square right away. Square both sides of the equation. Or let's find the square root of both sides of the equation right away. So on the left side, when we get the square root of the difference of x minus 12, what will be left is just x minus 12 because the radical sign or the square root sign as well as the 2 will cancel out. So what will be left is x minus 12. But on the other side, since 121 is a perfect square, so we just have to find out the root of it. So the square root of 121 is 11. But as I was saying, we are not only getting the positive root, but also the negative root. So that's why it's positive, negative 11. But looking at on the left side, it still has negative 12 here, a constant term. Positive and negative 11 is also a constant term. So we have to combine the two to come up with the final answer. So we have to move negative 12 to the right side of the equation, so that will become x is equal to 12 plus or minus 11. Then this plus or minus, we are going to form two equations separating this plus or minus. So we'll come up with the first equation as x is equal to 12 plus 11. Ito yung plus, while another equation is x is equal to 12 minus 11. Ito yung minus. Ito yung nandiyan kanina. Pinag-iwalay natin para malaman natin ng mas malinaw yung solutions to a given quadratic equation. When we answer this, x is equal to 12 plus 11, that will be equal to 23. While x is equal to 12 minus 11, that is equal to 1. So, the solutions of a quadratic equation, to a given quadratic equation, are 23 and 1. So that's how we solve a quadratic equation by using extracting the roots.
Nagustuhan nyo yung video na to, so just hit like, share this video, and also subscribe IGOP Lord official channel. So, importante is for you to subscribe the IGOP Lord official channel, and also don't forget to comment down below if you do have anything to say. So hanggang sa muli, goodbye!